I think that take away a lot of the class time. So we're just gonna be getting over that. So I guess I'll see you guys next week. Yolanda, you can carry on. Okay, I'm gonna see you
Okay.
guys later.
Okay, goodbye. All right, we have some mixed answers, I think. Remember, look at the last two numbers. That would be 92 here. And 92 is divisible by 4. So the answer would be yes. All right, divisibility rule for 5. You all should all know this. If the last digit is a 5 or a 0, then the original number is divisible by 5. Then we have 6, and as Sai was saying at the beginning, if a number passes the rule for both 2 and 3, it would be divisible by 6, since 6 equals 2 times 3. All right, yes, that's a good explanation for how to figure out if 92 is divisible by 4 in the chat. All right, now we're going to move on to 7. This is a more complicated one. You might not know this yet. So first, you have to take away the last digit and double that. So for example, you can type it if you want it, but we're just going to use this to explain. So you would take away 6 because that's the last digit, and double 6, which is 12. Then you subtract that double digit from the rest of the original number. So here, after we took away 6, we have 19 left, and you subtract 12 from 19 to get 7. If this number here, after you subtract it, if you get something that's divisible by 7, then the whole number is divisible by 7. And it can also be 0. But if that's a little bit confusing, I think we do have another example later on. So let's get past this. All right, divisibility rule for 8. You have to look at the last 3 digits of a number instead of the last 2, as you would do for 4. So here you would look at 128. Is 128 divisible by 8? Do you guys know? You can say it if you want.
Yes.
All right, excellent. 128 is divisible by 8. Therefore, 10,128 is divisible by 8. Now try it out for this one. Remember, look at the last 3 digits.
No.
Good. The answer would be no, because 242 is not divisible by 8. Okay, now we have 9. 9 is similar to the rule for 3. You have to add up all of the digits, and if that sum is divisible by 9, the original number is divisible by 9. So take, for example, 81. 8 plus 1 is 9, so 81 is divisible by 9. And 10 is obvious, the last digit would be 0. All right, here's another complicated one. The rule for 11, you have to alternate adding and subtracting the digits. So for example, you would add the ones digit, then subtract the tens digit, and then add the hundreds digit and subtract the thousands. All right, that's not a very good explanation. So it's probably better if we show it in an example. Here. Is 4,147 divisible by 11? All right, so the first step would be to add 7. We'll just skip past the answer right for now. The first step is to add 7, and then you have to subtract 4, because that's the next number here. Then you have to add 1, and then you have to subtract 4 again. And after you do all of that, you get the answer of 0. Hang on one second. Yep, you get the answer of 0. So that means that 4,147 would be divisible by 11. Does that make sense? Or would you guys like another example? Oops. Anyone?
No, I don't.
It
I'm
makes
good.
sense.
Okay. It looks like some of you are a bit confused, so we'll see if we can find another example. Okay, hang on one second. All right, I suppose I can just make up an example. So give me 1 second. Take the number 5,137. I'll type it in the chat if I can open it. 5,137. Thank you. Okay. What is the first step?
To take the last digit.
Good. So first you have to add the first digit. So you have 7. And then what's next?
I can't see
To add the 3.
Actually, you have to subtract the 3 because you added the 7. Now you have to subtract the 3.
Oh, right.
That's
I
okay.
can't
So
see the problem. I can't see the problem because it just shows me Divisibility Rules Example 1 and
can
nothing
you
else.
see the chat? I'm just using the chat because I don't actually have another example. So I just kind of made it up. So 7 minus 3 would be 4.
And then you add the next digit.
Good. The next digit would be 1. You add the 1 to get 5. And then the last step is to subtract what? What do we subtract?
5.
Good.
So
So
it's
5 minus 5 is 0. So is that number divisible by 11?
yes.
Good. Because the remainder is 0. And so that number is divisible by 11. Does that make sense?
Yeah.
Okay. Let's see. We're going to review the 7 because that one's also kind of difficult. Is 1,387 divisible by 7? All right. Do you guys remember the divisibility rule for 7?
Kind of. But that one's a yes. Because it ends in 7.
Okay. So the rule is to, you have to double the last digit and subtract that from the rest of the number. So
yeah.
you have to double 7.
Which is
And
14.
good. And then you subtract 14 from 138. So everyone do that. 138 minus 14. And then
124.
good. Then you have to figure out if 124 is divisible by 7. So is it?
No.
That's right, it is not. Okay, am I right on this problem for 2? To look at the last digit for 4. Yep, that is correct. So for multiples of 2, if you're trying to figure out if a number is divisible by 2, you look at the very last digit. If you want to know if it's divisible by 4, you have to look at the last 2, 8, the last 3, and 16, you have to look at the last 4. So for 32, you would have to look at the last 5 numbers and see if they're divisible by 32. Okay, so we're correct. 1,387 is not divisible by 7. Okay. Now, we're going to post these slides in the classroom. There are some more problems with explanations which you guys can work through if you're still a bit confused, but we really need to get through like this next topic because it's incredibly important. All right, so we're just going to start on this. Fractions, decimals, scientific notation, and percentages. What is a fraction? So it's any number that can be written like that. The top part, which would be where A is, that's called the numerator, and the bottom part where B is, that's the denominator. If the numerator is bigger than the denominator, then the fraction is called an improper fraction. And those are super, super important in math counts. A lot of questions tell you to express your answer as an improper fraction or a common fraction. So that means that you should not express your answer as a mixed number. An example of a mixed number might be 3 1/2. So does anyone know how to convert 3 1/2 to an improper fraction?
Yes.
You would
Yes.
You would do the denominator times the mixed times the 3, and then whatever, and then that equals 6, and then you add 6 to the 1, which is 7.
All right, excellent. That's exactly what you do. And remember, always simplify your fractions. Never leave anything as 2/4. You have to simplify that to 1/2 by dividing both the numerator and denominator by 2. All right, moving on to decimals. As you can see here, there's a decimal point, and everything after that, there's the tenths, hundredths, and thousandths place. Decimals are just like another way of representing parts of a whole. If you multiply a number by 10, you move the decimal point one spot to the right. So if you multiply this number down here by 10, then you have to move the decimal point to the right. So what number would it become? Do you guys know?
Wait, can you repeat that?
If you multiply 28.531 by 10, what would you get?
200.
250.31.
285.30.
285.31.
All right, good. It would be 285.31 because, and then what would happen if you what would happen if you divide 28.531 by 10? What number would you get?
It would be 2.8531.
Good, excellent job. All right, now we're going to move on to something a little bit harder, repeating and terminating decimals. So, does anyone know how to convert 1/3 into a decimal? Type your answer in the chat, please. All right, so I see you guys saying 0.33, 0.333, but that's not exact. You could go 0.333333 forever, and you would never
it never stops.
Yep, you would never reach the perfect value of 1/3. So that is what a repeating decimal is. But even though it goes on forever, it can still be changed into just one simple fraction. Not all decimals are like this. Not all fractions are like that. So, okay. So try converting 3/5 into a decimal. Three divided by 5. All right. 0.8, or is it 0.6? It looks like more of you guys are saying 0.6, and that would be correct. 3/5 is equal to 6/10. If you multiply the 3 by 2, and if you multiply the 5 by 2, then that equals 6/10, which would be 0.6. Because 6 divided by 10, you have to move the decimal point over, and you get 0.6.
Why would you only do it for the 2? Why can't you do it for any other number?
What do you mean?
Like you said, you do 5 times 2 and 3 times 2. Why?
Oh, okay. That's because I want the denominator to be 10, because that makes it easier to convert it into decimal. Decimal basically means 10, and so that's why. And so
Well, why couldn't you do like 10 to make it 100th?
I could do that okay, let's see. What would we have to multiply 5 by to get to 100?
10. I meant 20.
Yeah, okay. So we multiply 3 by 20, and we multiply 5 by 20, and you get 60 over 100. And that's the same thing as 6 to the 6/10. This would be 0.60.
So it's easy. So it's just easier to do it with a 10.
That's right. It's less numbers, less confusing.
Mm.
Okay.
Okay.
And this is a terminating decimal. It does not repeat. It does not go on forever. Yeah, we'll move on past this. Okay. Do you guys know why some fractions, how to figure out if a fraction is repeating or if it's terminating?
Maybe because
The
they don't
denominator
have a decimal form.
if the denominator so if it's
The denominator is not a multiple of 100.
if it's repeating, it goes on forever, and if it's oh no, wait, sorry.
If the denominator doesn't go into 10 or 100 or any like multiples of 10, then it repeats.
Yeah, that's very close.
If the denominators are odd.
Yeah, this is a slightly more, I guess, complete way of saying it, even though you guys are correct. So look at the denominator, see if it's divisible by 2 or 5. Then the fraction will terminate. So like 1/4, that's divisible by 2, it will terminate. But if the denominator is not divisible by 2 or 5, then the fraction will repeat. So like, let's see, 1/7, that will repeat. Does that make sense?
Yeah.
Okay, great. So, is 1/5 a repeating or terminating decimal? Say it or type in the chat.
Repeating.
Now remember, what numbers do you have to divide by? 2 or 5? You have to is 5 divisible by 2 or 5?
Yes, it's not a repeating.
That's right. It terminates because 5 is divisible by 5. Next one, 15 over 21.
It's repeating.
Yep. Why is it repeating?
Because it's not divisible by 2 or 5. It needs a remainder.
Yep, that's exactly why. And I think this might be the last one. I'm not sure.
Yeah, that one's a terminating.
Good, because 125 is divisible by 5. All right, now you've clearly got it. Okay, so let the other people answer. And we're going to see if they know it. 14 over 17, everyone.
That is repeating.
Good. It's repeating because 17 is not divisible by 2 or 5. And one more, 9 over 16.
Terminating.
Yep, that terminates because 16 is divisible by 2. Okay. I wonder what's next.
All the denominators with the prime number are a repeating decimal, right?
Sorry, can you say that again?
So basically, all the numbers with the denominator that's prime is a repeating decimal, right?
Yep. Exactly. Well, unless it's 2 or 5, because 2 or 5 are both, 2 and 5 are both primes as well. Okay. Percentage. Percentage is out of 100. 15% would be the same thing as 15 out of 100. Or any of those fraction or decimal equivalents. So here's a word problem. Lily has 4 oranges and 12 apples. What percent of the fruit are oranges? So remember, first you have to figure out the number of oranges, then you have to figure out the number of fruit. And fruit would be the number of oranges plus the number of apples. So be careful.
33.3333, and so on and so on forever. A percent.
All right, wait. So how many total fruit are there?
16.
That's right. So you have 4 oranges over 16. So what percent would that be? 4 over 16.
25%.
Yep, that's right. As you can see in the chat, 25%. So just be careful. Read the problems carefully. This is not 1/3. It is 1/4 or 25%. And here is Amy's lovely explanation for it. Okay, scientific notation. So you have this massive, massive number, or maybe you have this really, really, really tiny number, but you want to express it in a more easy way to read. And that's where you use scientific notation. So here you represent this big number as 2.3849 times 10 to the 22nd. So how do you convert to that? Oh, and here you can also write 10 to the negative 18th for the really small number. So here's what scientific notation looks like. You have a number a times 10 to some exponent, and a has to be in between 1 and 10. So to give you an example, let's take the number 237 and convert it to scientific notation. So first we have to get a in between 1 and 10. And to
It could
do
be
that,
anything, like, it could be anything under 4. It can be 2 or 3.
yeah, that's right. So 237, that would go to 2.37 because that's in between 1 and 10. It can't be 23.7 because that's bigger than 10, for example. And so then you have to figure out how many tens you took away to get it to 2.37. I wish I could write on this. That would be lovely.
You have to click on the annotate.
Yeah, okay, I'm trying to get it to pop up. All right, here.
We can write.
Draw 237. Oh, that's perfect. Can you guys see that?
Yes.
All right, so the decimal point would be right here in 237, but you want to get it to 2.37. And so you have to move it once and twice. And this is what n will equal. So it would be 10 to the second power, and a is 2.37. So that would be how you write 237 in scientific notation. And so what if you have, what if you have 0.0, oh, it's really hard to write points, 0.00237. So what would a be? Does anyone know?
Wait, can you just take out the front? Oh, no, never mind.
A is the exact same thing. It would be 2.37. And so now you have to count how many times you have to move the decimal point to get to that, to change this to that. And that would be
You have to move it 5 times.
2, 3. It would be 3 times. And since you're moving it this way, that's negative. That's making it smaller. So n would be -3. And so you get 2.37 times 10 to the -3. And that gets you 0.00237. Okay. Let's see. I'm going to get rid of all of this annotation. And now we're going to quickly run through a couple of problems. Don't want to take up too much time, but I want to make sure this makes sense. Oops. Okay, let's go through this. Not that one. Let's go to this one because this seems like an important problem to do. How do I get rid of that annotation? Try to get the meeting thing to pop up. Okay, now, do you all know how to solve this problem?
Yes,
I do.
I do.
All right,
2 times 2. You cut out the 2 from 1/2 and the 2 from 2/3 and simplify them. Which 1 and 2, 3, 4, 4, 5, 5, and unknown. So you'd only get 1/7.
all right, that's right.
Maybe the first numerator and the last denominator.
It's simpler than it looks.
Good. So basically, when you multiply, you have to multiply all of the numerators, all of the denominators, and then the numbers that are the same will cancel out. So 3 and 3 cancel out, 2 and 2 cancel out, 4 and 4, 5 and 5, 6 and 6, until you're only left with 1/7. And that's a much easier way of solving this problem than multiplying everything and dividing everything. And in math counts, you're going to have to look for shortcuts like this. And this is the same thing. Okay. Thanks. All right, now, this is not particularly important. Just if you're stuck, ask questions, ask for help. You can post it in Google Classroom chat. There's always an easy way to do a problem. Right here, this one deals with percentages. Do you guys read this through and see if you guys know how to do it? This one is a bit tricky.
$40.
All right. So if something is first marked up by 20%, then marked down by 20%, it's really easy to say that it would just be the exact same amount, but that's a common mistake, and here's why. So, oops, okay, that's interesting. The original price is $40, then it's marked up 20%, which is the same thing as multiplying 40 by 1.2, and that gets you $48. So after the first price markup, the shoes are now worth $48. And then it's marked down 20%, and you have to multiply 48 times 0.8. So that's the same thing as reducing the price by 20%. And that's actually less than the original price. It's 38.4. Because 20% of 48 is a lot less than 20%. Okay, what am I saying? 20% of 48 is more than 20% of 40. And that's why the price goes down to that. Okay, let's see what this problem is. All right, this is going to be the last problem, and then we're going to end this lesson, okay? So the factory sells 2.5 million gadgets. Okay. 2.5 million, 2, 5, 0, 0, 0, 0, 0. And then each of those gadgets cost $4.50. So they multiply 2.5 million by $4.50. And then you have to express your answer in scientific notation. Okay, this one probably, you could do it without the calculator. Definitely. It is really hard to go from annotating to back to the slide. Okay. Oh, here's another way of solving it, I guess. I'll get rid of these annotations. And so first you convert the number of gadgets to scientific notation. 2.5 million has, you have to move the decimal point 6 times, so that number would be 6 up there. That's the scientific notation. Then you have to multiply that by 4.5. And you can basically just multiply 2.5 times 4.5, and you get 11.25 times 10 to the 6th. But 11.25 times 10 to the 6th is not scientific notation because 11.25 is greater than 10 and it has to be less than 10. So does anyone know what we have to do?
Move the decimal?
You divide by 10. So, I mean, you move the decimal left once and add 1 to the exponent.
You have to move this decimal point 1 place to the left. And when you do that, you have to also add a number here because that's another movement of the decimal point. And so that's your final answer. All right, thus concludes the lesson. And there are a lot more problems that we didn't get to cover. So we're going to be posting those up soon, probably like in a couple hours after this. So you guys, if you want, you can take the time and go look through those. And yeah. Make sure you guys get the quiz done. There will also be another quiz on the topics from this lesson, and also the recording will be up.
Bye.
Thank you. Bye.
Bye, everyone.
Bye.
Thank you for coming. Goodbye.